All right, I'm going to go ahead and get started. I have a whole lot of material to cover in just 20 minutes, so going to jump right in. My name is Zach Rosenfield. I am a program manager on the SharePoint and OneDrive team, and we're going to talk architecture, service, back-end stuff. Whole lot of things we could talk about, but since we only have 20 minutes, we're going to do sort of a general overview of the SharePoint Online architecture, and then we'll go into disaster recovery and how we think about it in SharePoint and OneDrive. First of all, I've been on the SharePoint team since SharePoint Online was first started, and so I've seen this whole evolution of our platform. So really quickly, I want to kind of tell you about where we're at in our evolution as a large-scale service. When we first shipped in 2011, we really were just the on-prem product, same thing that you could install yourself, but hosted in the cloud. And over the years, we evolved to add automated systems to do things in an autonomous fashion, and then continued to grow in terms of how we thought about reliability and scale. You heard yesterday 100 million MAU. We've started to get very large. There was a time in our history, though, where upgrades took 6 months. It took us a really long time to do things, and so we had to start rewriting the actual SharePoint product, separating how it worked from the on-prem product to be able to do some of these things at such large scale. Right around 2016 is when we started to build features that worked only in the cloud. This is where we leveraged cloud-first technology and started to integrate with Azure. And then I'd say really over the last 3 years is where we've started to innovate and do cloud-first technologies and bring them into our product. I think Project Cortex is a great example of leveraging cloud-only technology deep within the SharePoint product. We're also very large. To support that 100 million MAU, we are in over 50 data centers in over 20 locations around the world. We're constantly adding new ones. There's data hosting in all regions of the world, so definitely recommend looking at where we can host data and making sure we're in the right locations for you. And then as we work to support that scale, we've evolved the architecture itself. So our original architecture in 2011 looked like this. And I won't go into the details on the architecture, but what you should see are boxes of boxes of boxes. And so every single one of those has to be individually understood, managed. You have to think about how do you handle availability issues, lots of concerns and bottlenecks in the system. And so over the years, we evolved. Our second key architecture, and if you've deployed SharePoint 2016 or later yourself, you might be familiar with some of these terms. We built this architecture here which has a handful of key roles. There's this bot role for handling background traffic, user role for handling end user traffic, and a cache server for being our in-memory cache solution. Below that, you can see we had a SQL environment. We were still running our own. And then we started to dip our toe into Azure and put files into Azure storage. And then over on the side, you can actually see this search service. That was our first attempt at really taking things out of the core SharePoint product and moving them into centralized independent services. This allowed them to scale independently. This allows them to think about reliability independently, but also for them to start working on other services. And so that led us to the architecture we have today. So we still have different forms of traffic, whether that be end users or service-to-service communication. We now route all traffic through the Microsoft front door. This is critical to our cutting-edge performance technology. I won't go into that here, but there is a talk at 10:55 in Theater 3, or 3, I believe, or 8. I'm in 3. In Theater 8, that'll go into details on performance. I highly recommend checking that out. Behind the front door, you will see the SharePoint Online service, and this is the replacement for what was on the previous slide. We still have this compute tier, so you still see that bot role, user role, and that cache role, but we added something new, microservices. These are independently scalable, runnable services that do things like notifications, that do things like media analysis and translation. These are things that we can leverage on top of our data, but are also usable by the wider Microsoft 365 ecosystem. So that way, when you're using file content in Teams, if it's stored in SharePoint, they can leverage all the same great functionality. And then we're all in on Azure. We use SQL Azure to store our databases. It's a key part of our DR strategy that we'll talk about in a little bit. And then we also, again, store all of our content in Azure Blob. And then behind that, we've continued to add to those O365 wide services. So you see things like audit, e-compliance, admin. There's a whole lot more that instead of building unique solutions that just work for SharePoint and OneDrive, these are really Office 365 and in some cases M365 Microsoft-wide solutions that we can plug into. And then we still run background services that allow us to do automated background tasks ourselves, and we've started to expose some of those externally, such as through the migration pipeline. So this is sort of the complete architecture. I see some people taking pictures, so I'll give it just a quick second. The other key thing that makes our architecture unique is that we are really a platform for customization. So unlike a lot of SaaS services that are really building for their own product, we are building for a wide ecosystem of products that will be built on top of us. Some of us, Microsoft, Excel, PowerPoint, Word, OneNote, Teams, there's a bunch, but there's also third-party, portals, your own custom applications. And then in the back end, we have Office 365 security integrations, we have information protection, and then I see a huge number of vendors here, and they all kind of fit in that bottom right corner where they're doing third-party scanning, processing, whether it be a CASB solution, AV scanning, whatever it might be. So there's a lot of folks running code on our ecosystem. And that creates a unique set of challenges for us. I'm going to go into sort of how we think about those challenges, but I have to use this opportunity for a quick public service announcement on customization, because I have your attention and I deal with these sorts of problems almost every day. So I want to make sure folks are aware, CSOM and REST were really purpose-built APIs. They were built for our UI, and they were built by a developer with a particular project in mind. And so when you use them, you need to have a real deep understanding of what they are doing. I won't go too deep, but this is straight from our TechNet. This is a very simple command. It says, give me all the items in this list named test. This is a horrible command. It has no select statement. So it might work well on your dev box, but when you put this in production and it runs against a list with 300 columns and 10 lookups and ties to taxonomy, it's going to get all of that content no matter which one of those fields you were actually trying to get. And then going back to that purpose-built concept, get by title is actually less efficient than get by ID. It's sort of a random quirk, but it's one of those things where you kind of needed to know what you were trying to do with it. And so I just give this example. I just called 4 different data sets the exact same data I'm trying to get every time, but I do it 4 different ways. And I can go from 1/4 of a second to 1/10 of a second. It might not sound like much when you're doing one piece of UI, you probably won't notice it. But if you're building an application that's going to scan through 10 million of your documents and do this on every one, that's going to end up being a whole lot slower and a whole lot less efficient. And that's why we really recommend anywhere you can use MS Graph. We got rid of all those weird quirks. We make it really hard to do the wrong thing instead of easy to do the wrong thing. There's a booth. I can see it from the stage right over there. If you have questions about using Graph, there's a SharePoint and OneDrive booth right over there where they can talk to you about it. And if you're going to scan content, I can't stress this enough, the only way to be successful in scanning content and making it really work well is following the guidance at aka.ms/scan guidance. So please do follow that. Back to how we in the platform deal with customization. So we have this big challenge. People write code, and code efficiency aside, we don't necessarily know what the intent of your code was. So a good example is, say we see in our data that a page took a really long time to load. We don't know if this was a home page that was slow because something went wrong in the service, or if this is a dashboard that you're going to put up in your lobby and you want all the data there and you're going to render it once at the beginning of the day and never again. So you're okay with the fact that it took 30 seconds to load. We can't necessarily tell that. And so we've really had to turn to data to detect patterns. so that we can understand whether things were intentional or whether things were platform-based. And so I mocked this up, but we've really driven into sort of tenant-level understanding in order for us to really represent what's happening in the system. So this dashboard, real data using an issue from about a year ago now, but we were looking at a region. If I want to zoom in here real quick. Maybe not. If you can see up in there, we go. Right here, so this is the team page load reliability. So how fast a team page load happened. 99.75% of the time, one of the tenants in our system was meeting the criteria we have for how fast it needs to load. So 0.25%, it's a pretty bad number in terms of bad experiences. And then we see that the region is 99.96, so better but still not good enough. And what we can't figure out is this tenant bringing the system down because they have some portal or dashboard that they've built that just has more on it, is slower, is not going to meet those expectations, or is there actually something wrong with our system? And so what we actually can see using data is if we separate out this tenant from the rest of the world, so blue is this tenant, yellow is the rest of the tenants in that region, we see a correlation where when one drops, the other drops. And through that data, we can determine this isn't a tenant-specific customization. This is something generic to all tenants in that region. We also have data that shows it doesn't happen in other regions. And in this particular case, we were able to map where all of the users in the world were versus where their data was, and actually see that there was a bad route between one part of Asia and one of our data centers in Asia. So we were able to go fix this issue and actually detect the separation between customization and between platform and our own internal systems. This is a case where we were able to sort of fix it on behalf of the user. I will say that a lot of the time we really find sort of unique, bespoke customizations that do very interesting things. This drives a lot of our best practices, so aka.ms/tune SBO. If you look at that, it really will help you with your customizations, making sure that you're not doing the wrong thing. And there's a diagnostic tool you can actually run, which will find sort of the most common class of issues for you. So we really want to get that information in front of you and your users. And so with that, for our first section, key takeaways. So we really are at a place where we are cloud first, next generation. We really want everyone to focus on best practices. We are working on getting smarter with data so that we can understand those patterns, find those things, and hopefully start to really surface them to you in the product. Make sure you're aware of things that you can do to make it even better, and really driving those things back into the system. So now we're going to talk disaster recovery. This is sort of the most requested topic that I get, so we want to talk about how we think about this at a service level in SharePoint and OneDrive. I don't have a ton of time, so I want to explicitly say you generally talk about these topics together. High availability and disaster recovery. We're not going to talk about high availability today. And the difference, just to make sure everyone is aware, high availability is really about handling regular failure. So what do I mean by regular failure? Basic example, say you have 100,000 hard drives. We have a lot more than that, but that's just an example. 100,000 hard drives, 1% failure rate every year means you're going to lose on average 2.5 machines a day. And you're also taking 10% of your machines out of rotation at any given time to patch and update. So you just have to know that you will lose machines while other machines, the redundant machines, are down for patching. So it just is going to happen. You consider it a failure, but it's a known failure. It will happen on a very regular basis. So you plan for it. You build redundancies into your system. It's just sort of everyday thing. Whereas disaster recovery is really about being ready for unexpected, catastrophic changes. So unexpected doesn't mean you can't imagine that it would happen, but you don't know when it's going to happen. So very real example that happened to us when lightning strikes your data center. When a data center is in the path of a hurricane. These are real things that happen to us. We know they could happen. We have to plan for them, but we get very little warning we don't get to plan for these ahead of time in terms of the explicit event. So I'm going to talk about how data flow happens in SharePoint Online, and I'm going to do that by showing you an architectural diagram that looks nothing like the last one I just showed you. Promise you that they are somewhat the same. Same three concepts as before. I have my compute tier, my metadata tier, this is SQL Azure, and my storage tier out in Azure Storage. So when a request comes in, let's say you're saving a file into SharePoint Online or OneDrive. First, it goes to that Azure front door, which will route it to the proper cluster for you. This is defined by the Microsoft 365 Trust Framework, so all about data compliance, making sure we're storing it in the right place. When it gets there, that is going to store the metadata about that file in SQL, which will instantly replicate into 3 additional synchronous copies of that data. Those will all be in the same data center region. If Azure availability zones are in that region, it will be spread across availability zones. And it will simultaneously store the actual file, the Word doc or PowerPoint or whatever you were saving, into the local data center and into the remote data center. So this all happens synchronously at the time of write. We will get back from Azure Storage a hash of the file. So we will get it from both Data Center 1 and Data Center 2. We will bring that back to that compute tier. We will compare it to the actual file that we still have sitting there in memory on that front end. And if all 3 of those look the same, we have it committed to all those locations. Only then do we tell the user, yes, we have your file. So at this point, the user has been committed to success. The file itself is in 2 physical regions. The database is in 1. And shortly after, we use SQL Azure replication to replicate the content in the metadata over to the secondary data center, where it also will have its additional replicas instantiated. So at this point, we have 8 total copies in SQL Azure. We have effectively 6 copies in Azure Storage. They use something called erasure coding. It's not literally 6 copies, but it's effectively 6 copies. And this way, if something happens to one of these components, say the compute tier and the front end fails, we can route traffic internally inside the Microsoft system. This is all internal to us. No DNS changes for you, no actual experience change on your end. We use the front door to route to the secondary location, which can talk to the local database. And it can also talk to either Azure Storage on either side. And in fact, we don't wait for a disaster to talk across data centers. On every single request, if we are unable to receive bits from the local store for whatever reason within enough time, we will go across to the faraway region. It obviously adds a little latency. We try to only do it when we have to, but any single request can actually read that content from either side. So we have our architecture. The next step of making sure this worked is automatic failover. So 4 nines is 4 minutes, 23 seconds a month. So if we are trying to be 4 nines, which is sort of the min bar we would expect, if I have to get a phone call, wake up, log into my machine, the corporate network, push some buttons, we've already missed our entire SLA for the whole month, and I haven't actually done anything with the service yet. So human intervention is too slow. You have to be fully automated. The other thing here is you need to make sure that if no failover has occurred, failover has no impact on end users. And this is important because you have to practice. We do over 100 DRs every single year in SharePoint. We do at least 1 a week. We want to make sure that when something really does go wrong, it's the thing that we do all the time, not the thing that we do on a rare occasion. So it's critically important that you be able to run it on real data, not just in a lab, on a regular basis. And then the other thing that I find interesting, doesn't get talked about a lot, is fail back is also critically important. People always want to know how fast can you fail over. But the reality is, if you can't fail back very quickly, meaning once you fail over, you don't have a secondary, anymore, you do everything in your power to not fail over in the first place. And this is definitely true of SharePoint Online in the early days. We would fail over, but it would take several hours for us to get a new secondary, and that was scary to us, so we do everything in our power to wait and delay. And so the longest that we could allow for a DR to take, we would take all that time to try and fix it in place. So this is actually just as important as being able to fail over fast, is being able to turn back around. And SQL Azure has really been key for us in terms of being able to do this. There's still room for us to improve. I'm going to talk to you about something we are building. This is in dog food right now for Microsoft, and we will get this out as soon as it's ready to everyone else. But we also want to get to a place where we are active-active. So this just means that instead of only routing requests to one environment and sending it to databases on that side, we want to actually get traffic running to both sides simultaneously. So some content is being served on the right, some content is being served on the left. We're already doing this for storage. It allows us to have smaller failover units. So the smaller the failover unit, the quicker you can choose to do failovers, so those automated failover heuristics, we don't have to be as careful about them. And then also, it's just smaller. Everything's simpler, more reliable, less chance for failure. And then we avoid this rusty secondary problem. I liken having a warm standby to just basically having a spare car in your garage. You can test the battery, you can try it out, but you don't really know if it's going to work until you get in, you turn the key. And so this really ensures that you have been actively using all your environments all the time, and you know they're ready to go. And the final thing on recovery I always like to point out is that disaster can happen at other levels than just the service. So ransomware, accidental delete, malicious deletes, these are all real scenarios that can happen to your users that are still disasters. We do have stuff built in the product to solve these things, so do make sure your users are aware of them. Files restore is my personal favorite. You can go back in time to anywhere in the last 30 days, every single change that you've made on a site in the last 30 days. So there's great stuff here to make sure your users are ready. And unfortunately, we had not very much time. So disaster recovery, I went over the plan that we have in place. We're continuing to improve and make it better. Things like active-active, our roadmap there. And then we do have user-facing tools to help with end-user disaster as well. And with that, thanks for coming out. I'm going to be hanging out. I'm over time, so I'm going to come hang out over here. If anyone has questions, please come chat.